Welcome back. We're now at Worksheet 9A. In the next preview assignment and in the next class, you will need to be able to solve problems using graphical representation and use symbolic models to find exact values of variables. We're going to start with depreciation. Over time, some items become less valuable, and one example is a car. You pay one price for a car when you buy it new, and then over the years, the value of the car decreases. The car becomes used because the parts wear down. It might get scratched and dents, and the interior of the car is not going to be as clean. And so when you try to sell the car back 6 years later, you're not going to get the same price. People may rather have a car with newer technology, and then the loss in value over time is depreciation. This is a great time to hit pause and go to at least question 1 by yourself, and then come back and we'll work through this on the video together. Question number 1. Suppose you bought a new car 4 years ago. We're going to call this year 0, and it was $18,000. This year, you look up the value of your car and it's worth $12,000. Assume the value of your car is linear of how long you have owned it. Part A, write the data as ordered pairs in the form of age, comma, value. Age, comma, value. So let's start with the first one. It's 0 years old when you first get it, and the value is $18,000. And just a side note, when I'm dealing with coordinates and I have a number like 18,000, which normally has a comma in it, I usually leave those out to avoid some confusion, where 0, comma is for the X part, and then the rest is the Y. You don't have to, but it can avoid or help save some confusion. They want us to do this for both pairs. And so that's when you first bought the car, it's new, no years old, $18,000. And the other is when it's 4 years old and it's valued at $12,000. Part B, find the slope of the line between these 2 points. And we do have some prior work, and we do have a resource in your My Math Lab in course student materials about slope. You can also search the internet to look for other forms and ways of doing slope. After we calculate the slope, we're being asked to write a contextualized sentence describing the meaning of the slope's value. As I've mentioned before, every time I think it's really important that we write down the entire formula for slope. Excuse me. I think it gets it into our fingers and in our brain, and we start to make fewer mistakes if we go ahead and write it down. The other thing I really think it's important to do is that you go ahead and label one set of coordinates with the sub 1s and one set of coordinates with the sub 2s. And then we can just follow the pieces and parts and plug in accordingly, like Y sub 2 I have labeled as 12,000, minus is from the graph, and Y sub 1 is 18,000. X sub 2 is 4, minus X sub 1 is 0. When I subtract these, I'm getting negative 6,000 over a positive 4. And when I go ahead and divide, I get negative 1,500. Well, that's great, but it's asking me to write a contextualized sentence. And that's where I think it's really important that we write the words that if we're talking about X and Y, and it really helps me to see it this way. X, that's going to be our years, and Y is going to be our value, our money. And if that's the case, my change in Y, that's the money. My change in X, that's the years. So with my answer over here, I like to put it in 2 parts. So what it's telling us is that we're going to go down $1,500 for every year that we own the car. Or we could say for every year we own the car, we're going to go down $1,500, and that is a contextual sentence about how to describe the slope. Part C, write the slope-intercept equation that models the car's value as it increases with age. We know one equation together, and it's the y equals mx plus b. So y equals, do we have a slope? Yes, we do. There's our y equals mx. B is the y-intercept, and that's where x is 0, and our y in this case is 18,000. So we now have our equation, slope-intercept form of the car's value as it increases with age. If you haven't already paused and haven't already done question 2, this is a good time to hit pause, do question 2, and then come back and let's work on it together. Cars lose value, both with increased age and increased mileage. Up to a point, some very old cars actually start to increase in value again. But according to the Kelley Blue Book, in June of 2018, a black 2014 Chevy Cruze 4-door Ellis sedan with standard options in excellent condition in Austin, Texas with 25,000 miles has a trade-in value of $8,168. Same car, same time, same place, 30,000 has a different trade-in value. Assume we're talking linear, and then part A. Write the data as ordered pairs. I like to come back over here and look at my graph. Which would cause which? And cause and effect are not the best mathematical words to say. They help my brain to see that the more miles, the less the value. In other words, we were over here at about 28 or 25,000 miles and we were here, and then at 30,000 miles we were here. And if it's linear, it makes sense that the more miles we have, the less the value is, or the price that somebody's going to pay for the car. Excuse me. So let's write the data as ordered pairs, and looks like it's going to make sense to do miles and then money. If that's the case, the first one would be 25,000 miles is $8,168, and the second is 30,000 miles and $7,985. Part B, find the slope of the line between these 2 points. Don't round your answer, and then write a contextualized sentence describing the meaning. Slope is the change in y over the change in x. Our y involves the money. Our x involves the miles. Our formula is this. And I'm going to go up here and label. Somebody's got to get the sub 1s, and somebody's got to get the sub 2s. So I'm going to mark them as you see. I'm going to start plugging in parts based on my labeling and the formula. And I'm going to grab a calculator. It says do not round your answer. Let's find out what's going on. So I'm going to type in 7985 minus 8168, and I'm getting a negative 183. I'm going to do 30,000, not sure why, but typing in 30,000 minus 25,000, and I get 5,000. When I divide 183 by 5,000, I get a negative 0.0366. They asked us not to round, but just leave it here. And they're wanting us to explain the value. So I'm going to scooch up right here, and I'm going to rewrite that the slope we got is about negative 0.0366, which is tenths, hundredths, thousandths, 10,000ths. It's 366 10,000ths, and I like to see it over 1. Remember a while ago, it's money to miles. So we are going down that much cents for every 1 mile that we drive this car. We're going to keep going with question 2. Part C says we need to find the Y-intercept. And a while ago, it was kind of nice that the Y-intercept was handed to us. It said something like the original price of the car was $18,000, so that meant time was 0, and it cost us $18,000 for the car. So why do we need to find the Y-intercept? Well, it'll help us to know what we knew a while ago, the original price of the car. Part D, how are we going to find this Y-intercept? Because it wasn't as cute as it was a while ago where they literally just handed it to us. We're going to have to do a couple of steps. I've mentioned to you having a glossary or flashcards or Google Doc. The process we're about to do is worth setting apart and noting of how to find a Y-intercept when given 2 points. It says, write the equation of the line relating trade-in value and mileage in this form, but leave B unsubstituted since we don't know its value. Well, I'm going to move it up here just a little bit. Y equals mx plus b. And right now, the only thing we know is the slope that we just calculated that was about 3 cents, almost 4 cents a mile is what we're decreasing. So it says write the equation of this line and leave b unsubstituted since we don't know its value. So we wrote the equation. It then says solve for b by substituting either, big note there, either of the ordered pairs that we had. I always try to think lazy and pick the smallest one. They're both kind of sizable, so I'll just go with the first one. Solve for b by substituting either of the ordered pairs into part A. So from here, I'm going to go ahead and pick on the 25,000, 8168 ordered pair, and remember, you can use either. And I'm going to plug in, this is my X, this is my Y. So I'm going to plug in my Y for right here. I'm going to plug my X in at the X value spot plus B. So you need to make yourself some notes of what we just did. We started with a slope-intercept equation. We plugged in the slope that we know. We then plugged in a point that we know, and we left B alone, and now we're going to go solve for B. So in my calculator, I'm going to put these two numbers together. I'm going to put 25,000 times 0.0366 negative equals. I'm looking at 8168 equals negative 15 plus B. Excuse me. That leaves one step to add 915 to both sides. Sorry, I'm out of space and jamming it all together here, but I'm going to take 915 and add it to 8168, and I'm getting that B is worth 9083. So it stands to reason that our starting price for this vehicle was $9,000, and then in 25,000 miles it went down to 8,000, and in 30,000 miles it went down to just below 8,000. But back to part E, solve for B, we did. And then it says, let's plug all of this in. Whoops, am I there or am I jumping the gun? Nope, I'm jumping the gun. So go ahead and look at part F. And part F says, and let's put it all in there together. So for Y equals mx plus B, I'm going to need to plug back in Y equals, not another point, but the parts that are the Y-intercept and the slope. There's my slope, and here's my Y-intercept. Through several steps, we now have an equation that's going to give us information about this particular car. Not only did we talk about depreciation at the first of this lesson, we now need to talk about solving for an unknown variable. In the next class, you'll need to know how to input values for one variable and then solve for the unknown variable. The following equation shows the value of a machine after a certain number of years in use. V stands for the value. That's the value of the machine. And Y is the number of years. And I think I'd rather use something like T because it can be confusing that Y is going to actually end up being on our x-axis. So I may want to use T for years. I know it makes sense, Y for years, and then V for the value. Write a contextualized sentence describing what the values this and this mean regarding the machine's value. So 100,000 is right here. And although they have this formula written like this, they've got that first and the slope, which is by the x. This is still the y-intercept. So 100,000 is the y-intercept, and that would be the original or initial cost of, I think they're calling it machines. So it's the original cost of the machine. This negative 16,000 right here, that is the price. We've decreased $16,000 every year. It's our slope. If you haven't already tried question 4, this is a great place to stop, pause, get an answer for question 4, and then come back and let's do this together. Use the equation to find the value of the machine at the end of 3 years. So value is what we're looking for. They want us to use this equation. So I highly recommend you write it down and then plug in whatever it is you know. And we know that 16,000 times 3, because it's 3 years. And so now let's do some mathematics. But let's just be real careful that we follow the order of operations, because in order of operations, we need to make sure that we multiply first. Excuse me. So I'm getting 100,000 minus 48,000, and that would be so we use the equation, we have found a value, and we found the value at the end of 3 years being $52,000. As we're finishing up this lesson, if you haven't already stopped the recording to do some of the problems, go ahead and do 5 and 6, and then come back and we'll work them together. On question 5, I went ahead and wrote the formula down from the past problem because it asks, is it possible to make mistakes when using formulas? And then it says, the most common mistakes have to do with order of operations. And what mistake might lead someone to this answer, even though the machine started at 100,000, but after 3 years, it now cost or is worth 252,000. Maybe it's an antique model. Maybe there was some mess up on the order of operations. So here's the formula, the equation. And a while ago I said, remember, you got to make sure you multiply first. Well, we did, and we got our answer of $52,000. But what if somebody decided to subtract first? So I've got 100,000 minus 16,000, and I get 84,000. Well, it's already wrong. It's not going to equal this. I'm going to go ahead and put a frowny face because it's already been, we've messed up. And so our answer is already bad. But let's just follow through and then multiply it times 3. And when we do, that's how we could get the 252,000. But it's not reasonable. And so part B says, is that a reasonable answer for the value of the machine? If the machine starts at $100,000, unless it's by some odd circumstance, it's not going to all of a sudden increase to $250,000. So think about reasonableness, and also remember, make yourself a note. You got to follow the order of operations. If you've got some parenthesis work, you got to do that first. In exponents, the multiply and divide left to right, and add and subtract left to right. One of the cool things I like about solving equations is the power and the flexibility, manipulative ability of the different things you can do with equations. For example, it says, hey, let's go back to the equation one more time. So the value is $100,000 minus $16,000 times the years. You can put Y or the time. And it's going to ask us a different question, same equation. Determine how long. In other words, we're looking for T. The company should keep the machine until its value is all the way down. The value is all the way down to 15,000. And then they give us a hint. We're going to have to input 15,000 for the value solved for the years, and then they ask us to round our years to the nearest tenth. So let's do it. Let's put 15,000 in for the value. Leave everything as is. Everything as is. And then we've got a two-step equation. Two-step equation meaning we need to move the 100,000 first. And a reminder, we have lots of tutoring services. If this is not making clear sense to you, you can always Google, you can watch the video over, you can take this worksheet into tutoring and say, request for someone to explain it to you in person. And I have office hours. Those are listed in my syllabus. You're welcome to come join me in office hours. Also email. Several people will email questions by taking a picture or just emailing the words. There are many resources for help. Make sure you get those resources for help. So when I subtract my 15,000 minus my 100,000, I'm getting a negative 85,000 equals a negative 16,000 T. Remember, we are trying to solve for T, so we've got one more thing that needs to go. So we will divide by a negative 16,000. All of this becomes a 1. And so from here, our time or our years will be whatever negative 85,000 is divided by 16,000. I'm not even going to mess with the negatives because a negative divided by a negative is a positive. So I've just typed in the positive versions and I get this. And I go back and reread my directions and it wants it to the nearest tenth. So the years, I look at my tenth, the 1 says stay where you are. And so my time for this to reduce or the value to go down to 15,000 would take 5.3 years. This completes this lesson 9A. And you need to look at your syllabus to see if you have more lessons to do for this week's deadline, or if you need to finish this up and upload it to D2L. I'll see you in another lesson very soon.